Hello, everybody. Thanks for joining today's webinar. We're going to cover today Internet of Things powered predictive maintenance for machine builders. This is kind of an interesting concept. As I hand things over to our co-hosts, you're going to learn some things, hopefully from a different angle than we've talked about before. I know Indusoft, we've typically talked about gathering data and being able to use that kind of from an end user level. These guys are going to take things from a slightly different angle and talk about it from the machine builder angle. So got some really good information. Just some logistics before we get going here. Number one, we can't hear you on this type of webinar, so if you have any questions, put those into the chat panel or the Q&A panel on the WebEx interface. There is a questions and answers section at the end, so get your questions in early. Also, you will be receiving a follow-up email announcing a survey. Please let us know how we did today. Let us know if there's any feedback. The more information, the better, so we can improve these webinars. We've done over 150 of them now. They're up on our website, and if you want to request a topic, well, that survey is the place to do that. But please take a look at the website under support. There is a section there for the webinar videos. And again, we've got over 150 of these things now, covering just about every topic that you can imagine. But if you want to see more information on a particular topic or want to request a new topic, let us know there. Also, there is a field there for letting us know if you would be interested in co-hosting with us. We'd love to have you on, get your company some free advertising. And then last but not least, if you give us your shirt size, we will send you a free T-shirt just for joining us, just to show our appreciation. So, and again, for those of you who didn't hear, we're going to be recording this webinar, and that usually gets posted up on the website usually within just a few days. So, my name is Scott Courtier. I'm Senior Technical Sales with Indusoft, and I'm going to give you a brief introduction to Indusoft, but more particular is how it relates to what Karthik and Srinath are going to show you in their demonstration. So not a whole, I think I only have 4 or 5 slides that I'm going to cover, and if you've seen Indusoft presentations, you've probably seen these slides, but it's just going to kind of set the foundation of what they're going to talk about. Then I'm going to hand it over to them. They're going to talk about their application and what they're doing, and show you a demonstration, then we'll open up for questions. So again, get your questions in early on the chat panel so we can make sure that we get those answered properly. So a quick introduction to Indusoft Web Studio. I see a lot of new people on the webinar. Hopefully you're familiar with us in some form or fashion. If you didn't know, Indusoft Web Studio is very easy to use, very powerful, and very flexible, yet still very affordable HMI and SCADA software. Some people know us as very low-end HMI and don't realize that we can do SCADA-level type applications. And some people know us only as the upper end and don't realize we can do the lower end as well. So just want to make sure that that was understood. And you know, since our early beginnings, we were really entrenched with Microsoft as far as the ability to run on really anything Windows, whether it be Windows CE and mobile, Windows Embedded, Windows Desktop and Server editions. But now we've kind of opened that up and understood that there are many other platforms out there, especially in the industrial world. The ability to run on Linux and VxWorks, and as you'll see, also the ability to view and interact with your projects on really any operating system via browser, whether it be an Apple, a Macintosh, an iPad, an Android smartphone or tablet. So really, again, it's not just Windows-based. It's really very platform independent. Going through the next slide, we've got these 3 kind of horizontal slices here. The idea of portability, being able to develop once and deploy on any of these operating systems for runtime, whether that's a desktop or server edition of Windows, an embedded version of Windows, compact edition CE, or even Linux or VxWorks. So again, very scalable from an operating system standpoint. The mobility section here really highlights our 3 different types of thin clients. And I'm going to focus here on this rightmost one, which is what we call our SMA thin client, which really gives you the ability to open up any HTML5 browser whether it's Safari, Chrome, Internet Explorer 11, on any of these different operating systems, and be able to, again, view and interact, of course, with security in mind, with your screens remotely. Then the interoperability, many people will think of an HMI or SCADA software as only being able to communicate with PLCs, but it's so much more than that. It could be temperature controllers, barcode readers, drives, robots, and then databases, network management tools via SNMP, or cloud-based systems. There's a driver that we've added called MQTT, which is really, in addition to OPC UA, taking a foothold with cloud-based architectures and Internet of Things based architecture. So this really leads to end user and machine builders productivity, reliability, and security with all three of these things. So taking a look at that portability slice a little bit further, again, one development environment will allow you to create a project that you can then deploy on all of these operating systems. I recently worked with a customer and developed an application that they had on Windows CE. Took the exact same application, deployed it on a panel-based industrial PC on Windows Embedded Standard 7, and then published those screens and then viewed them on tablets and smartphones. So all with the one development environment, deployed that one project in their lab, and they were very, very happy about that. So again, that idea here of the three different types of thin clients, I'm not going to highlight each one of them, but I think Karthik and Sirinath are going to mention the SMA client in their project, and again, that's able to run on any browser that's HTML5 compliant, specifically Safari, Chrome, Internet Explorer 11. There's a related browser to Chrome called Chromium that'll run on Linux, and so all of those options. The interoperability piece of this is that if you look at this diagram as Indusoft Web Studio tags at the core of this, we can basically get information from any device, database, OPC, client, or server architecture, or the internet into Indusoft Web Studio, and then share it with any of these other devices. If you notice, these arrows are bidirectional. So really kind of a neat idea is being able to take maybe not only a PLC, but maybe devices that you wouldn't ever think of being able to get information into a database, maybe a legacy-based serial RS-232 or 485 based temperature controller, get that information into a database, or from one brand of PLC into another brand of PLC. The fact that we can use simultaneous drivers and communicate to different brands of PLCs, different models of PLC simultaneous, can offer up a big advantage in this type of architecture. So speaking of architectures, many of our customers will run on a panel PC on a local machine, typically as you'd see here in this lower right corner. Display maybe without a display, but display remotely, maybe in a control room environment on a video wall matrix. One of the coolest things I've ever seen has been an application where there was 8 70-inch monitors tied together displaying Indusoft Web Studio. That was very, very big application. And then again, with the three different types of thin clients, you can run on a server in plant in your facility and then be able to view those stations remotely, maybe with the thin clients or even in the cloud. So many, many different ways to deploy and use and interact with Indusoft Web Studio. So hopefully I've set the tone of this. I'm going to go ahead and hand things over to Sirinath.
Thank you, Scott, and thank you. Hello, everyone. Thank you for joining this WebEx. I and Karthik are going to take you through the next few minutes. To start with, I'm going to introduce my company and talk about what we are trying to solve as a context building for this session. And then I'm going to have Karthik take you through the system live in action and then take some questions at the end of the session. So that's our plan for the day. Saxon Automation is a company been operating for more than 15 years, and we operated across 12 countries. And we offer solution product engineering, essentially focused in the space of which is the cusp of industrial automation, industrial IT, and digital manufacturing. So we bring in all the three skills together to deliver some valuable capabilities to our customers at variety. Now, I want to talk about the kind of markets that we focus is around the discrete space, consumer packaged goods, food and beverages, automotive, and some utilities. But our approach to the market is we work essentially through system integrators and machine and equipment builders and automation companies across the world. And that's our go-to-market. So we actually work and supplement along with them our offerings to the customers. And if you really look at it, we are also certified for CSI certified company and also a CMMI level 3 development certified. That brings kind of maturity to our capability to deliver these projects across the world. And what we see as a result is about 95% of our customers are repeat customers who come back to us with different problems, different challenges, and we go through those to actually solve them. So this is our background. And I have Karthik who's joined. So he's essentially responsible for the U.S. operations, and he's going to be taking a part of this webinar for later. So I want to set the context. So we do hear a lot of digitization of businesses that's going across the world, and there's a lot more attention to this space and this understanding now with manufacturers. And I think this has evolved over the last few revolutions. So I just don't have to talk a lot about it because we already know that smart manufacturing industry 4.0 is actually the order of the day. All the end manufacturing companies are looking to do what can they do with this kind of a technology, which is coming together. But what's important that we wanted to discuss is how does a machine or an equipment company leverage this trend that the manufacturers are trying to accomplish, and what can they do about it to enable the manufacturers? So the first thing they can definitely do is to enable digitally their machines so that these equipments can connect to the factory systems and plant floor systems and allow these manufacturing companies and users to actually innovate their business. So that's the first thing definitely the machine builders can enable. The second is the larger part of the discussion for today is in the process of doing this enablement, the machine and the equipment companies can also benefit greatly from this technology evolution. So they can leverage the digital capability of their own equipment to improve their time to market, they improve their machine capabilities, as well as enable with some very valuable services that their end users can pay for them on a services model. So this is what we are talking about, and the technologies that are coming together here are very many. Internet of Things, artificial intelligence, machine learning, augmented reality, these are all coming together to enable this capability. The machine builders also have a benefit of doing this with respect to their being able to increase their top-line revenue and differentiate their machines and equipments. At the same time, look at how do they understand their machines and equipments better so that they can improve their processes to reduce their costs. So it's a double benefit on both sides, and we will talk through some of these as we go. But there are challenges because if you really look at the machine and equipment world, there are about 60 million of them right now working through us in various factories of the world. 90% of them are not connected. This was a recent survey done, and that's a bigger challenge. And more than that is a bigger challenge that 70% of these machines are older machines, and they're not enabled to do this. So that's the world we are living in. While there's a lot of benefit in connecting these equipments and collecting data and doing a lot of things, there are challenges associated with that. But the forecasted figures are by 2020, 62% of the machines will be connected, which is a good news because I think the attention that's coming on to the smart manufacturing is going to enable the end users holding the requirement for these machines to get connected and to collect data and to present data in different forms. So that's going to drive some kind of change in the way we enable the machines and make them connected. That's one of the primary drivers of what's going to change in the equipment machine world. But this is just a trend, but what is the real benefit? Now, if you really look at a few decades back, maybe about 15, 20 years back, we looked at machine and equipment just as a machine which produces products, and incidentally, they will also produce waste. They don't like it, but they do produce it by putting in raw material, time, people, and energy into it. The view of the machines was looked at more as just a production equipment. But there was a powerful amount of information that was getting produced in these machines, which can be leveraged, which was something that has evolved over the last few years, that people are looking now at just not the machine producing products and waste, but also looking at how the machine can be leveraged with the information that's collecting in that process. That's a powerful way to look at what the machine is producing. Now, the data that machine produces are of different types, and one of the significant amount of work which has gone in the last few years is around how the data can be used to benefit the manufacturer or the end user who's producing these products, buying these machines. So they looked at how can I understand the productivity, the efficiency, the quality, and what's causing the downtimes, what are the plant KPIs that I can understand from the machines. And this has been a great amount of work which has gone in terms of providing manufacturing intelligence and various other dashboards that can help the manufacturers of the products to benefit from it. There is also another possibility and an opportunity, which is at the very early stages of adoption, is about how can the machine builders also use the same machine data collection unit to actually look at their machine health, and then look at how do they can provide some insights for themselves in terms of redesigning their machines in the next generations, or they can look at how these machine data health can be repurposed back to the end users to know about failures that they may be seeing happening in a few days, hours, whatever, in a real-time basis, and kind of give an alert system for them to be able to manage that data. So that's the power that is possible with these two data. And a lot of work which is going on right now and dialogues going on between the end users and the machine builders on how do we manage this data for both the purposes, for the purpose of the manufacturer and for the purpose of the machine builder. And it's not an easy conversation, and most times it needs quite a lot of engagement to convince through all the concerns that the end users would have about security and other reasons that they would not want to look at all the data. But then there is a value in providing some of these data back to the machine builders because they understand their machines. And if that data is available to the machine builder, their ability to improve their machines and to help the end users back again to add significant value is going to increase tremendously. So that's the dialogue that's happening, and that needs to happen more. But having said that, what can this data take us to? So, of course, at an initial point, I mean, the data, if you all know that the biggest nightmare for any production manager is based in unscheduled downtime. And there has been a lot of evolution in the way the machines or the production is getting maintained, right from a time-based to condition monitoring. And now, of course, we're talking about anticipatory maintenance. Now, what do I mean by anticipatory maintenance? Essentially, there's one fundamental difference in the way the machine components work, and it depends on what environment it is subjected to. So a mining equipment that works in open environment in an Arctic zone could be very different from that works in a foundry in a controlled environment. So the basic assumption about all machines can work exactly in a predicted way based on a condition in a particular environment is being challenged because they are subjected to differences in the way they operate. And also there is other dimensions coming as to how the machine operators are interfaced with the machine. There are other complexities coming in terms of what's been the maintenance routine of these machines. And there are SLAs and other requirements that are coming up from the end users, which is creating a lot more interest and challenge to the machine builders on how do they deal with this. So the primary goal being that to benefit that there's to be reduced downtime, and the ability for these equipment data to be able to enable that is a fundamental interest on both sides at this point. And what can this do over a period of time is this partnership between the machine builder and the end users actually can completely transform the way the machines are today purchased to how actually they are serviced, or there could be an opportunity for the machine builders to move the machine from a purchase model to a service model. And that's the power of collecting. And it's very important the machine builders actually understand how their machines are functioning in different environments before they get to that commitment of giving the machine as a service, because they then need to run their ability to get paid for their machines is completely dependent on how well the machines are running in the manufacturing plant. And it would be very different in different kinds of environment or different kinds of plants. The other part of change is, of course, an opportunity again from just being a provider of parts and a maintenance contract to an ability to actually provide a lot more services around predicting the machine components' capability to function and when they would fail, which in turn would be a great value when served to the end customers as a service. So there is an opportunity for creating ongoing revenues, increasing their customer intimacy, and it's also making a services as a business model for the end customer. So this is a compelling argument for this change to be initiated both from an end user perspective as well as from a machine builder perspective. Having said this, it's a journey. So it's not going to be a flip of a switch. It's going to be a gradual process of understanding where today the machines are. Like I said earlier, 70% of the machines are old, 90% of them are connected. Now, where do we start from? Essentially starting connecting these machines in the plant floor. So that's an opportunity for equipment builders to go back to their end customers and have a dialogue on how they can help some of these upgrades. Some of them could be just enabling them with an extra. And today there's a lot of IoT-capable sensors that are coming up, which primarily can take data without having to really retrofit their control system. So that's possible that they can do it at a lower cost as well. So the machine connectivity is fundamental. And subsequent to that is where I said that they can look at how the data is collected, what data can be collected, and how it can be presented back to the manufacturers to benefit from what they can understand from the machine, and then enabling the machine builder themselves to offer some services as a machine as a service, and that kind of integrated to going to the next level of giving some high level of analytics around the machine functioning and giving that anticipatory maintenance capability. So different machine builders, different manufacturing plans are in different points of this journey. We see most of them in our experience are somewhere in between the machine data integration platform and machine as a service. Some are at a fundamental level, but largely we would say there's a lot more interest in this space. And a very few of them have gone to using the machine-to-machine learning or analytics to really get to the next level of capability. So that's primarily what is the journey that is going on. I wanted to hand it over at this point to Karthik to actually show a work that we have done with a machine builder. This is, again, a journey. We are working with this machine builder, so I want to hear from Karthik as to how you can see some forms of whatever I talked through in action, and then we can have some question and answer at the end of the session. Thank you very much again for joining us. Karthik, over to you.
Karthik, are you there?
Yeah, I am, Scott. Are you able to hear me?
I can hear you great. So I'm going to make you the presenter now, and you should be getting that shortly. And don't forget to share your screen. That looks like it's coming up well. All right, there you go. I'm going to mute certain asset myself, and go ahead, sir.
All right, thanks a lot, Scott, and thanks everyone for joining us today morning. And thanks, Srinath, for the great intro. So, as Srinath suggested, I mean, this is a journey that we have been taking with one of our customers. I mean, we know them for the last 5 years. And to give an introduction about the client, this client, they create special purpose machines for the automotive industry. They have two products, one for the exhaust lever assembly and the other for the rocker lever assembly. So currently they have about 500 plus installations across the world. And right now we have been working with them for the last 4 to 5 years. So while we were working with them, one of the major problems or major pain areas that they had was the ad hoc service requests and the broken SLAs, which are proving to be very expensive for the company. the service cost was almost zooming up to 18% of their revenue against probably an industry average, which is about half of it, about 5 to 8%. So this had a direct impact on the margins of the machines and obviously had a potential impact on the business competitiveness as well. We know how the automotive industry works. So with our association, so while we are trying to kind of solve this problem, I mean, how to address this and make this much more streamlined, we were also thinking, okay, well, now that we are going to promise higher productivity to our customer, we are going to kind of invest in the systems which are going to deliver a higher service level. Is there a possibility of monetizing this as well? Because when we are selling the machine, we are selling productivity to the customer. So is he ready to pay a certain amount if we are able to promise a certain amount of productivity? So that's where this journey started, and we started working on it for a few months now, and we proposed a new solution. So this solution had the power of both Indusoft Web Studio, as Scott just gave an introduction, the portability, the mobility, the SMA capability. So that we took the power of the possibilities of what Indusoft Web Studio can give into an enterprise analytics solution, and we combined both of this to deliver a predictive maintenance solution. So typically, if you ask me to describe this solution, we can say that it's an integrated subcomponent level condition monitoring and analysis solution, which will kind of give you data points which are traditionally ignored, and a powerful analytic system that will kind of help you to kind of make sense out of this data and address these service problems, and probably even smartly address these service problems. So this is how the architecture of this particular solution looks like. So this is a very high-level architecture. We are not getting into the details of it yet. So that the machine is at the end customer level, and we have the option to collect the data from multiple sources. As Scott said, kind of Indusoft gives us multiple ways to collect the data. On the security front, we will be connecting it through the regular VPN. I mean, whatever you have enabled in the end customer has enabled, and it will pass through the firewall. The OEM side or the machine maker side, what we will have is the enterprise network. So we are using the power of Indusoft on the left hand side and the enterprise network on the right side. But since the amount of data that is going to be coming in is going to be huge, and also the amount of processing power that will be required to take real-time decisions will be huge, we are also kind of leveraging the cloud infrastructure here. So moving on to the next slide. So right now, we have kind of trialed this solution in a specific region in India, and the kind of benefits that we are right now seeing is that there is an immediate 20% reduction on the service turnaround time, and we are also seeing a forecast of about 18% increase in how we are going to sell the product plus services component. So without any further ado, I'll move on to the live demo. So just give me a minute to share my screen. Okay, so Scott, are you able to see the dashboard here?
I can. Looks good.
Okay, all right, thank you. So the dashboard that you're seeing here is basically the enterprise system that we are talking about at the OEM level. So after considering the problem from various perspectives, we proposed an integrated subcomponent level condition monitoring system that can be used to optimize the service operations. So right now, at a higher level, what you're looking at is the geography, is the dashboard that allows you to go and monitor the health of your health of the machines that you have installed at different client locations. So right now, I'm going to choose a particular region. So this region kind of tells me shows me the plants where my machines are running. So the performance parameters that we are at a high level monitoring for the rocker lever assembly and for the exhaust lever assembly. So this will give you a very high level KPIs of availability and performance. So right now I see that one of the plant has a problem here. So when I click on it, I get the parameters shown on the right hand side. So I see that there is a drop in the availability of the plant, and that's the reason there has been an alert on this plant. So I can go ahead and check the availability across the different plants. So now that we know that there is a problem with this particular plant and the availability is pretty less, so I'll be able to drill down into this plant and get into my line and get into my machines here. So here, this gives a very high-level snapshot of the parameters that we are monitoring on this plant. So this tells me, how many number of service requests have come out of this plant, and how many have been assigned, how many have been unassigned, how many of them are preventive in nature, how many of them are going to be predictive in nature in the next 30 days. So that kind of high-level information is available for the maintenance department. So I'm going to choose my plant. So this will be a very familiar screen for most of you. As Scott said, this is a high-level application that is built on Indusoft. So here we are seeing the line of that is working in that particular plant, and I'll be able to drill down into the specifics of this line. So here in this line, we are seeing that there are more than 8 stations that are running on this plant, and we are monitoring all of these parameters individually. And we also have a line level KPIs that are being monitored at this point of time. So right now, in this demo, we will simulate a fault, and we'll drill down and we'll get into the problems of why or the whys of that particular problem. So now that you can see that status of this particular station has changed to red, which means that the station has come down. So a lot of alert and even management or even maintenance systems will kind of stop at this level. They will say that, okay, in this particular plant, the productivity has gone down because this particular station is not working. So yeah, that is a good amount of information that can be used to kind of optimize your service levels. But what we promise here is much more real-time and much more granular. So what we have done is that we have allowed further more subcomponent level investigation into this station. So now I'm going to drill down into this particular station. So this is going to tell me what are the operations or what are the components that are involved in that station. And we see that all of these have gone down. So to understand the reason, so what we do is we get into the maintenance. So now that we have drilled down into a particular geography, we drilled down into a plant. From there, we went into a line. From there, we went into a station. And within the station, we are able to see even the different components that are available in that station. And we are able to identify what has failed and why it has failed. So that's the power of the solution here. So right now we can see that there is an O-ring cylinder that has gone down, and why it has failed is that it has kind of gone past its average service life. So the average service life was certain amount, and now the operation is completed, is way ahead of it. So this is the reason that this particular plant availability has gone down. So at a macro level, when you're seeing the availability has gone down, but if you want the most micro or the most granular amount of data, we know that because of this particular single cylinder part that has failed, the entire plant availability has gone down. So this is the kind of granular and exhaustive data that we are able to kind of bring with this solution. So now we see that there is a failure here, and you can act on it. So instead of just identifying the solution and telling you why this particular problem has happened, we added another layer there. So here on the bottom right, you can see that we have the instructions laid out for an operator who's trained to kind of go and change the system or kind of go and solve the problem right away. So even in a case, if the operator is not trained or he is not familiar with that particular problem, so what we show here is that is a tag. So this tag will be available to the operator. So the operator can use his mobile device to scan this particular tag, and he will have a 3D instruction of how to fix that problem. So I'm going to just run a recording of that video at this point of time. So yeah, let me start it from the beginning. So how it happens is, so once the operator scans the tag that is attached to the machine, so we give an augmented reality experience to the operator. So you can see that the entire machine is simulated here, and he will be able to kind of, I don't know how many of you can see the instructions here. So at the bottom right, you can see that check the LED indication valve. So that is a valve that is blinking on the machine. So it is saying that, okay, the operator has to check. This is the first step you'll be kind of taking care, and then take him through the entire operations. So one is that this immediately gives an immediate solution to the problem. And next is that, the service turnaround time. If the operator can fix it, or this also can be accessed from a remote location. The operator just gives a call to the maintenance department. The maintenance guys can kind of scan the same tag, and they can access the real-time parameters of this machine from a remote location. So that is the power of the application. So there, again, they can guide the operator. So instead of traveling to the location, trying to figure out the problem, what has happened, so this can happen in real time, and it can happen remotely. So bringing down the service turnaround time hugely. So now let me go back to our demonstration here. So now that we know that something has failed, and we know that why it has failed, and we know how to fix it also. So now we will acknowledge it. The other, since we are monitoring all of these operations at the same point of time, so if you can see here at the right corner, the insert valve cylinder, we see that there is an average service life of certain amount, and now there is a certain number of operations that are being completed. So while I'm attending to this problem, I can also see that there could be a potential mishap in another few hours or in a couple of days that's going to come up. So this is where the predictive analysis piece of it comes into play. So this predictive analysis is built on one single parameter at this point of time based on the number of the average service life of that particular cylinder provided by the manufacturer of the cylinder. So this can be extrapolated to multiple parameters if you have the data, and based on that, we will be able to kind of put in some data science and bring in the predictive solution as well. Again, for the same fault, you can see that the steps to attend to that, and also the tag through which you will be able to get an augmented reality experience. So now, what we have done is we have attended to a problem. We also seen what has failed. One of the other major business concern or a macro concern when you're talking about SLA-based business contracts that you can monetize has been the transparency of the data. So when you, as a machine maker, when you go and talk to your end customer saying that I'm going to give you a certain amount of uptime and this is what you will pay for it. So most of the times what has happened is the machine makers had less amount of data, or they did not have a validated data to go and prove their point saying that it is because of some other fault this has come down, or not because of the machine. Most of the times we realize that with the machine manufacturer, the operators are not well trained, and because of that the productivity has come down. But that directly impacts the SLA, and SLAs are tied to money. So that has always been one of the holding factors for machine makers to take this route. Though everybody wants to take that product plus services route, this has been one of the limiting factors. So right now we have the technology. I think we have the solution also in place to kind of address that problem. So now we have seen the real-time data. So now as probably a head of maintenance, I want to look at some historical data as well. So I'm looking at the previous shift. So this screen gives me a very high-level analysis of what are the parameters of that particular shift. But I can specifically get into details, like what are the cycle time. So here, if you see, it gives me the cycle time analysis of all the eight operations sequences that needs to happen in that particular station. So here I see that in one particular operation, the cycle time is more than what was designed. So this is the historical data, but I don't know why it has gone down. So one of the things that I can do is, or how much it has gone down. So one of the things I can do here is that I can again go back to my augmented reality thing. So I can again switch back to my, I'm sorry. Yeah. So here, what I can do is, as a maintenance engineer, I can at real time I will be able to connect to those PLC tags, and I'll be able to read those real time information into this augmented reality scenario, and I'll be able to study this cylinder, saying that okay, did this cylinder perform in this way so that the cycle time has gone down. So this is the analysis that I'm talking about. So here, this is the historical data. So I'm able to pull that data into the simulation of the cylinder, and I'm able to kind of plot a chart there. So this is all done remotely. Okay. Yeah. So when we see that there is something that has gone down or there is something wrong, we are able to kind of connect to the PLC and get real-time data, put it into our simulation, and see that what has gone wrong. So it really gives you a powerful way to get into and address the problems, and also allows you to kind of go and present to your end customer saying that this is what exactly happened. This is the black box that we're talking about. When you see a flight recorder, there is a black box which will give you the information about what exactly happened. So this is validated, recorded, and real-time data that you can go and present to end customer saying that because of this, your productivity is coming down, and doing these changes, you will be able to increase it. So that's the value a machine builder can bring to the end customer, thereby opening an opportunity to monetize that kind of a service. So not just cycle time analysis, since this machine has a couple of cameras also installed, so we will be able to pull data out of that and give the information about how the operator acted on that particular machine using the camera details, or we can even drill down to the operator efficiency, saying that how this operator worked on it. So if a customer says that, if an end customer says that the productivity of this particular machine is not as per promise, we can go back to him with granular data saying that this is how the operator is using the machine, and this is the camera output, this is the cycle time analysis we had, and these are the other the granular data that we have collected, and because of this productivity is going down. So overall, what we have done is we have taken the power of Indusoft to collect a large amount of data, and also the portability of Indusoft to kind of connect to multiple devices. For example, in some cases where the machines are not as smart as you want them to be, they're legacy machines. So in those cases, we might just add a on-edge device. So there Indusoft plays a role and kind of picks up. It's pretty easy to synchronize with Indusoft, and we'll be able to pull up the data, and we connect that to a very powerful analytics system. So combining both of it, we have been able to kind of deliver a solution to the machine makers, with which they can first reduce their service turnaround times, increase their machine efficiency, increase their machine availabilities, and also look at new streams of revenue with new SLA-based business contracts or something like that. So this is at a maintenance level. So if you're looking at a business level, so we have more dashboards lined up here. So if you are looking at the revenue details, so for example, I'll just highlight this, the customer-wise analysis. So these are the customers who are already on contract with me, and these are the service revenues that I'm expecting, and these are the service costs that I've already undergone. And in some cases, am I breaking the SLA, and is it going to cost me so much of money? Am I profitable, or am I going negative in that area? So from a component level, we saw that we were able to kind of diagnose that a particular cylinder has failed. So from that level, we are kind of zooming it up and taking to a bird's eye view and telling you that with this particular customer, because of this particular problem, and you are going to lose this so much amount of money, or we are saying that you're able to kind of make so much amount of money because you're delivering that amount of productivity to the end customer. So basically, this is what this short demo was about. I hope everyone was able to get a good amount of information here. So I'll switch back from this demo to our screen. Yeah, so that's about it with the demo. I hope you liked what we had in offer.
Guys, thanks. Can you guys hear me?
Yes, Scott, yeah.
Perfect, thank you. Well, I've opened up both of your lines, so you are unmuted. Just to let the audience know, we have it open for questions at this point. If you have questions or comments, please put those into the chat panel or the Q&A panel on the WebEx interface. We'd like to hear from you. What you're seeing now is some contact information for Srinath and Karthik from Exen. They should be able to answer questions. I have a couple of questions since we don't have any questions in from the audience. Can I have you guys expand a little bit more on the augmented reality? For example, like whose augmented reality are you using? Is it Microsoft's HoloLens, or what is that?
Karthik, you want to talk about that?
Yeah, sure. The enterprise system that we are using here is ThingWorks. So ThingWorks has a platform for augmented reality called Vuforia, which is pretty much built into the system and makes it a lot more easier to integrate with an enterprise level software. So we are using the Vuforia platform of ThingWorks.
ThingWorks. Okay, great. And then another question is, you guys showed a lot of for lack of a better word, a template for a particular machine builder, or how they might be able to expose that information. How much time do you guys have to spend with a machine builder to build? Is it a dedicated, customized system, or is it, is it something you have to work with each individual machine builder, or is it a template-driven system so that it can be kind of customized on the fly?
Yes, so Scott, there's two parts to this. One, of course, is the dashboards, the information, how we present it. The second is a very fundamental layer, which is understanding the mechanics of the machine and making sure that we are looking at the right components and the right data to identify what we need to collect data on. So the presentation layer is reasonably quick to do. I think where there's a lot of engagement and time goes with the machine builders is in terms of identifying what's the right information, what's the right mechanics to use to collect the understanding of the component that is being used in the machine. Now, what we are trying to attempt to do is as we are working with a lot of machine companies, we're trying to make these components subcomponents. For example, if it's a wall, or if it's a cylinder, if it's a motor. Now, we're trying to templatize a lot of these as libraries eventually so that this can become a lot more easier to build and develop for various kind of machines. So that's the direction we are going in. But right now, it takes a lot of efforts to actually understand the various subcomponents involved in the machine. I hope I answered that question.
Yeah, I would agree with that, because I've spent some time developing projects with some companies, and I get there and they don't know what they want, and you have to go through extensive questioning to help them understand what they want to get out of it. So I could just imagine that being a relatively long process, and with your experience, be able to get that information from them quicker than somebody who's not familiar with that type of system. We had a question come in. What about exporting data from the application?
I think you want to talk about that.
Yeah, I mean, this. I know it's about exporting of data, but it comes with a little less of context. So the entire data is kind of connected to the cloud platform, and is also available through your analytics of your enterprise system. So if you want to kind of create dashboards, you create it in your enterprise system. And if you want just the raw data that you want to kind of download and use it for some other reasons, I'm sure there will be avenues available to connect to the cloud, and you'll be able to download the data. I don't know if that is the right answer for that.
Yeah,
because I don't have the context.
Are there reporting tools, like can you press a button and get a PDF printed, or other reporting tools? Yeah, definitely. I mean, for example, this is the revenue details that I was talking about. I mean, we can also look at some of the dashboards that we have here. So this maintenance dashboard. So all of this dashboards has been created using ThingWorks Analytics here, and I'm sure that kind of export that into a PDF or probably just send as an attachment on an email. And also, the backend is going to be SQL, as it's going to be an SQL database. So you will be able to even kind of export data in a different format and use it in a different analytic tool if you want to. Great. Another question came in. How are you applying machine learning, and what tool are you using if you're doing so?
Yeah, so machine learning right now, we are the initial phases of doing some POCs with the same customer and on some concepts. So we're going to be using the same ThingWorks platform. There is an analytics capability in that platform to be able to do the machine learning capability. So we are at a phase where we haven't fully developed it, but we are in dialogue in terms of identifying the right areas where we will be able to take it. This is in the when I talked about the maturity curve of the equipment, this is the last phase that an equipment company can take it to at this point. And it's a journey, so we are walking through that at this point. So, but the platform that we are talking here is very capable of doing that, and we will be able to collect. So, our fundamental thing is we got to be able to collect some level of data to be able to interpret and understand the patterns that are coming out of it. So, we are at that phase right now in understanding what the data is to be interpreted, and how can we interpret and then take it out to the next level of machine learning.
Great. Let's see if there's any other questions. Do you take into account the environment that the machine is running? For example, a NEMA 1 rated machine versus a NEMA 4X. So, for example, is it in a harsh environment, a dusty environment, an explosion related environment? Do you take any of that into account as well? So
the eventual the idea that I presented earlier, and we're talking about identifying what are those environmental possibilities and conditions, and then putting the right amount of ability to collect that data. And very much it's a part of the plan to incorporate. At this point in the work that we have so far done, we haven't incorporated that. There is a discussion going on what could be all the conditions that could actually make a difference to the subcomponents, and then looking at that. So specific to your question, we have the ability to do that, but we haven't done that in this specific example.
Okay. All right. We've had a few more questions come in. I'm going to combine these into just a couple. Is this a relatively new system, or have you deployed this to? How many plants have you deployed this to? And kind of what are the quantities that are out there? Is this a relatively small number, or is this something large? And is it? I think you had showed in one of your slides that it's not only automotive, but it's packaging, it's food and beverage. What type of industries do you see the kind of major acceptance for this?
Yeah, so at this point, we are at the point where we're doing a lot of proof of concepts along with the equipment companies and machine companies to the end users, and trying to facilitate a dialogue of having this information available as well. Because it's a process, so it's not very easy. Once the machines and equipment goes into the manufacturing plant, there is some interface, some dialogue we need to have with the end customers to be able to get that machine data back, and we kind of work to convince the end users that you don't really need to send us the production data. We just need to understand the machine. It's kind of a black box kind of a concept for the machine. So at this point, we have, with this machine, with this builder, we have at least ran this to about 4 or 5 installations so far, and it's been running for some time collecting the data. Now, if you look at, we are at different phases of POC with different machine builders. So relatively, this whole concept is very, I'm sure it's pretty advanced in many parts of the world, but it's relatively new in a country like India. But we are working through with the equipment people across the world to see if we can incorporate this. At this point, it's mostly on a POC, on an experimental basis, collecting data from multiple beta sites.
Okay. Yeah, I'll say that there's a lot of talk about this and a lot of articles being written, and I'm seeing very few actual installations. Everybody knows it's a good idea, but taking the time and making the effort to actually do it is another thing. Everybody claims that they don't have enough time to implement this type of feature that would give them more time. So it's something that has to come from upper management and be implemented in the grand scheme of things, as opposed to maybe driven from a controls engineer standpoint. It's more of a management standpoint.
Yeah, and I agree with you, Scott, because one of the fundamental shift that we have made able to make this machine builder believe in and is able to do is put the basics of collecting data and an infrastructure in place with every machine that he supplies. So last time we talked to him, he said, by default, from now onwards, all my machines goes with this default option of collecting data. Now, whether it's enabled or not is a dialogue that he would have with his end customer. And even if the end customer wants to enable that at a later point after he sees and believes what he's talking about, he's fine with that. But he's taken a fundamental shift in saying that every equipment that I will ship now will go with this pre-enabled to be able to be capable of. And because when the customers actually would ship, and that is not the time when you start thinking about the infrastructure, right? So you got to pre-enable it so that when customers want to do it in larger scale, it's already enabled in the machine.
Yeah, I also found that once you get started, it's a little bit easier to modify and make changes than it is to get over that initial we need to do this, so we need to start doing something. Maybe a first phase is take the general idea of doing it, collect the information that's easy to collect, and then learn from that, and then make adjustments and changes.
Sure.
Would you agree? Yeah. Okay. Well, I don't see any other questions coming in. Gentlemen, do you have anything else?
Right now.
Thank you very much, and I just wanted to appreciate everybody's time spent with us today.
Yeah, thank everybody. Thank you, everybody. Thank you, Karthik and Srinath, for doing this. I learned a lot. I like seeing this kind of information. Again, we had it open to questions for a little while. I don't see anything new coming in. We're going to go ahead and end the webinar now. If you need to get a hold of us, again, the recording of this will be up on the website in a few days. Here's some contact for Indusoft. We have the contact information for Extend up here. And so if you need to get a hold of us, let us know. Again, on that survey, let us know how we did today. Fill out your shirt size. We'll send you a free T-shirt just for joining us. We really appreciate having everybody in today. Hopefully you learned something. I think this is a great idea conceptually from kind of instead of targeting the end users, targeting the machine builder platform side of things. So, gentlemen, thank you for presenting. Everybody, thank you for joining us. And Karthik, Srinath, thank you very much. Appreciate it.
Thank you, everyone.
All right. Thanks a lot. Thanks, everyone.
Absolutely. All right. With that, we're going to end today's webinar, and we'll see you hopefully on another one. Thanks.